Launch 3D Experience by opening the CATIA Part Design app through the compass. Click the plus and select Import to import the file downloaded in step 1 of the written instructions. Change the file type to 3D XML with authoring and locate the file. Then click OK. After the file has been imported, close the window. Search for car clay model in the search bar and open the model. With the model open, go to the compass and open the app Simulate a Fluid Scenario Creation to create a new fluid simulation of the model. Right-click the scenario in the tree and select Properties. Change the title of the scenario to Car External Flow CFD Simulation and click OK. Open the Assistant from the toolbar if it is not open already. Select the Model tab of the Assistant and you will be prompted to create or select a finite element model. Select Create and click OK. Now we will define the fluid volume using a bounding box. We will only simulate half of the car since the results will be symmetrical. In the Model tab of the Assistant, select Fluid Domain. Under the Parts tab of the new window, click the plus. Select all parts in the model by clicking and dragging your cursor over it. Then click OK. Under the Exterior Boundaries tab, select Bounding Box as the boundary type. Enter the values shown for the X, Y, and Z limits. Make sure to turn on boundary layers for the bottom Z-plane. Under the Regions tab, click the plus. Select a face on the car that is inside the bounding box. Make sure the glyph points away from the car, otherwise click Flip Direction. Then click OK to close the window. Now we will define the material of the fluid. Under the Model tab of the Assistant, select Fluid section. Select the Fluid Domain glyph as the support. Under Material, search for Air. Then click OK to close the window. Under the Physics tab of the Assistant, select Physics Behavior. Accept the default values shown and click OK. We will now define the mesh for the model. Under the Mesh tab of the Assistant, select Hex Dominant Mesh. Set the size of the mesh as shown. Check the box to add boundary layers and enter the values shown. Under Local Specifications, select the little box icon to create a local mesh sizing Cartesian box. Enter the values shown and click OK. Select the little box icon again. Enter the values shown and click OK. Click OK to exit Mesh Editor. In the toolbar, click Update to view the mesh you have just created. We will now create a steady state step. Under the Physics tab of the Assistant, select Steady State Step. Set the max iterations to 2000 and click OK. We will now define the air velocity at the inlet. Under the Boundaries tab of the Assistant, select Velocity Inlet. Select the front face of the bounding box as shown. Make sure the direction is normal and set the velocity to 50 miles per hour, include the units. Then click OK. We will now define the pressure at the outlet. Under the Boundaries tab of the Assistant, select Pressure Outlet. Select the back face of the bounding box as shown. Make sure the static gauge pressure is 0 and click OK. Since we are only simulating half of the car, we need to tell the solver that the setup for the other half of the car is symmetrical. Under the Boundaries tab of the Assistant, select Symmetry. Select the interface of the bounding box as shown and click OK. Now we need to define if there is slip on the sides of the bounding box. Under the Boundaries tab of the Assistant, select Wall. Select the outer and top faces of the bounding box as shown. Set the wall type to slip. Then click OK. The bottom face of the bounding box will be left as no slip. We will now define what type of output the simulation will have. Under the Simulate tab of the toolbar, select Output to create an output request. Select all faces as the support. Do this through the tree as shown. Set n equal to 100,000. Change the output group to field. Expand flow, select Walsher. Expand turbulence, select Listen as star. Then click OK. Select Output again to create another output request. Select all faces the same way as in the previous step. Set n equal to 1 and change the output group to history. Expand flow, select force, press force, SOM, and Vike force. Then click OK. From the toolbar, open the Feature Manager. Double-click Fluid Physics Defaults 1. Set the velocity to 50 miles per hour, include units. Then click OK. Under the Simulate tab of the Assistant, select Simulate. Accept the default values and click OK to start simulating. After the solver is finished, the results will generate. View the different contour plots for pressure, velocity, and velocity vectors. We will now generate the contour map results along streamlines. Under the Plots tab of the toolbar, select Streamlines. Change the seed support to rake and enter the values shown. Expand options and change the thickness to 4 mm. Then click OK. Using the same process as the previous step, create 4 more streamlines with the values shown. Now that the streamlines have been created, we want to show the car and hide the outlines of the bounding box. Under the View tab of the toolbar, select Rendering Settings. Select Show Geometry, then click Close. Open the Feature Manager from the toolbar. Double-click Gauge Pressure 1. Switch to the Rendering tab. Under Visible Edges, select None. Then click Close. Notice the changes to the streamline plot. We are now finished with the activity.